Hello everyone, myself Dr. Triparna Saha, and on this particular lecture series that is on pattern recognition. So far we have covered about the basic concepts of Bayesian decision theory. To apply the Bayesian theory for the classification purpose in pattern recognition, what are the much needed technologies or terminologies that you need to know that we have covered so far in the first two videos on the Bayesian decision theory. Today we'll go into the classification problem using the Bayesian theory, and that will be the fourth video of this pattern recognition lecture series. So let's start today's video. Today it will be about Bayesian network. So for this Bayesian network, that is based on the concept of probability. So let us just recapitulate some of the fundamental knowledge about probability. So all the probabilities are between 0 and 1. That is probability of anything, that is probability of A. The value can be greater than equal to 0, or if the value can be less than equal to 1. Valid propositions or tautologies have probability 1 and unsatisfiable propositions have probability 0. Probability of true is 1 and probability of false is 0. The probability of a disjunction is described probability of A union B, that is probability of A union B, plus probability of A, that is hold the green thing, plus probability of B, that is hold the pink thing. Now, there will be probability of A intersection B, that is this part will be common, right? So this part will become 2 times. As for probability of A is this thing and probability of B is this thing. So this particular part will become 2 times. So that we need to subtract 1. So probability of A plus probability of B minus probability of A intersection with B. Now in the Bayes rule that we have covered so far, that is probability of A intersection of B equals to probability of A with the prior occurrence of B multiplied by probability of B. Same thing can be repeated here. Probability of B with the prior occurrence of A with probability of multiplication of probability of A, and probability of B with the prior occurrence of A, that is the probability of A with prior occurrence of B multiplied by probability of B and divided by probability of A. So if you cannot remember this thing, let us just go to some of the previous slides where you can get that this has been already taught. Just think this is already been discussed. So those are the things we are covering once again to just give you the recapitulation, and that you can understand much better the next slide. So what is the joint distribution? That is the joint distribution of probability of x1, x2, x3 up to xn. That joint distribution we are trying to find out. That value will be equal to probability of x1 with the prior occurrence of x2 up to xn multiplied by probability of, that is the joint distribution of x2 up to xn. Now this part will become over here. Now this you can represent in the similar fashion of that we have represented here. Probability of x2 with the prior occurrence of x3 up to xn multiplied, then this thing will be again multiplied by, it will be probability of x3 up to xn. That can be again you can write. So this will be the final equation for the joint distribution. So this is the thing, that is probability of x1 up to xz equal to summation of I is equal to 1 to n probability of xi with the prior occurrence of parents of xi. Now the Bayes network. For this Bayes network, let us consider this particular problem has been given to you. So what is the problem? That is the burglar alarm problem. So if there is a burglary, alarm should be switched on. That is the thing. So burglar alarm at home you have, and this particular alarm is fairly reliable at detecting a burglary, and it responds at times to minor earthquakes as well. So not only burglary, if there is a minor earthquake, then also alarm will go on. Okay. So in these two cases, alarm will be switched on. That if there is a burglary or there is a minor earthquake. Okay. Now there are two neighbors. Two neighbors on hearing the alarm call police. Suppose in your home you have a burglar alarm that will be switched on for burglary and minor earthquake. Now you have two neighbors. One is John, another one is Mary. These two neighbors on hearing that alarm in your home is going to call the police. John always calls when he hears the alarm, but sometimes confuses the telephone ringing with the alarm and calls then too. That is, in your home you have a telephone as well. So the sound of the alarm and the telephone ringing is very much similar. So John gets confused. So if whenever gets the alarm, whether from the burglar alarm or from the telephone ringing, it is going to call the police. Now, Mary does not always call, as Mary likes loud music and sometimes misses the alarm altogether. So in Mary's house, that is one of your neighbor's house, there is a loud music always playing. So due to the loud music, it sometimes misses the burglar alarm. So it's not always going to call the police. That is the scenario has been given to you. In that scenario, you have represented the belief network. So what is the belief network? That is, if there is a burglary, then alarm will be switched on, and if there is an earthquake, then also alarm will be switched on. So this is the belief network. This probability of B and probability of E, these values are given to you. Now, with B and E are the parents, the probability of A. So that is, if any of them is true, the alarm should go on. And that is the values, as you can see, that is very high if the burglary has happened. And if this is false and earthquake is true, then this value is quite a bit small. And if both of them are false, this value is very less. This table is also given to you. Now, the John calls. When John calls, there is an alarm. The alarm will be the parent of the John call. If there is alarm, then only John is going to call and then only Mary is going to call. If this value is true, then this value is 0.95, as John always calls for the alarm, whether it's the alarm, burglar alarm or the telephone ringing. Always John calls, so that is why this value is so high. But Mary sometimes misses due to the loud music playing at Mary's home. So that is, this value is listed. Table and the values have been given to you. But you can draw this belief network, I guess. That is, this arrow will be from the cause to event. That is, this is the cause, and based on this cause, this event is going to occur. This is the now cause, so based on this cause, these two events can occur. So based on the from the cause to its outcome, there will be the arrow direction. This is how belief network should be drawn. So this is the network. Now let us try to calculate the probability of, that is a joint probability of John calls, Mary calls, and alarm and burglary and earthquake. The 5 events suppose are happening at the same time. So the joint probability we are going to calculate. So this will be this equation based on the previous equation, this particular equation, that is the joint. So what you can write over here? Probability of John calls with prior occurrence of Mary calls, alarm, burglary and earthquake. That will be probability of Mary calls, alarm, burglary and earthquake, the joint distribution. Now, this thing you can see over here, this should be the parent, right? Why? See, this should be the parents of xi. So now, come over here. Now, what are the parents of John call? There is only one parent of John call, that is the alarm. No other parents are present over here. So all the other parts will vanish out. That is Mary calls, burglary and earthquake doesn't have any direct effect on John calls. Burglary and earthquake have indirect effect, but there is no arrow between them. So the indirect effect, or where there is no connection, those will be vanishes out. And this is the same thing. Now, take this part as it is. Now this part, it will be Mary calls with prior occurrence of alarm, burglary and earthquake, and the joint distribution of probability of alarm, burglary and earthquake. Now this will be the parent only. So Mary calls parent is only alarm, that is a direct effect have. So that is there, otherwise vanishes out. Now this part we are again expanding. So it will be the probability of alarm with the prior occurrence of burglary and earthquake, and then probability of burglary and earthquake. Now this part is same. Now this is we are again expanding the probability of burglary and earthquake with the prior occurrence of earthquake and multiplication of probability of earthquake. So this is now probability of, just take this probability of burglary with the prior occurrence of earthquake. But there is no direct connection. There is no connection between burglary and earthquake. So this part will be vanishes out, and this will be this part only, probability of E on. That probability of B multiplication of probability of E. So this joint distribution function will be represented by over here. Now the values are already given. So you can just put the values and calculate. So this is how you can calculate the probability values using VB. I hope you have liked this particular video and happy studying.